So we're still in Unit 2, Numerical Summary of Data. 3.2 is Measures of Spread. 3.2 has a lot of information in it. First, it starts with the range, which is the largest value minus the smallest value. So the average monthly temperatures in degrees Fahrenheit for San Francisco are as follows. So 63 is the highest or the largest, minus 51 is the lowest, so 12 is the range. Next, we talk about standard deviation. Standard deviation, we're going to be calculating. It's the measure of how far the values in the data set are from the mean on average. So the distance from the values, it's like the average from the mean. And each data value is taken into consideration. So first you start, well, it depends if you're talking about a population or a sample. We're going to calculate population standard deviation first. This is the formula. Before you square root it is the variance, but this population standard deviation is the sigma symbol, and here's the formula. And if it's a sample, the formula adjusts a little bit. The S is for sample standard deviation, and you have to minus 1 from the sample size. So notice this is going to be each data value. Then we need to know each data's value's distance to the mean. We're going to square those values, take the sum of that divided by the total sample size and square root. So this is a big long table that we're going to be doing in the next problem. Okay, so the same problem, we have the average temperatures for San Francisco. So I have a sample size of 12 because there's 12 months. We're going to compute the population variance and standard deviation. So this is the formula that we need. So each of this X is going to be the 12 months, the temperatures of each month. The mean, well, we have to figure out what the mean is. The N here is 12 because there's 12 months. So I add all these temperatures up, divide by 12 to get the mean. Then I'm going to need to find each temperature's distance to the mean. If January was 51, that is 6.5 degrees below the average. In this column here, we're going to be squaring this number because we want to get rid of all our negative signs. So I'm just going to go ahead and square that while it's here. (54 minus 57.5 squared is 3.5 degrees below average. After I squared it, it's 12.25. Well, this is 2.25. 58 is above average by half a degree. Two and a half degrees above. Hopefully you're doing this along with me. 52. Okay, so we completed that. The formula wants us to add this whole column up. The sum of this column, is 169. So the population variance. The symbol is sigma squared. It's before you square root it. So I take this 169 and divide by 12, my sample size. Two decimal places. So the population standard deviation is the average distance from the mean for each month is going to be the square root of this. Now, I do not put the rounded number in my square root symbol. I do the fraction. Round to 2 decimal places. Oops, that's a 5. So the mean temperature for all 12 months is 57.5. But the average distance from the mean is the standard deviation of, give or take, 3.75 degrees. That is not a large spread. It is a measure of spread. But imagine if this was New England. We have a huge spread in our temperatures. So the average distance is very small to the mean, the standard deviation, 3.75. Again,